Good morning, everybody in YouTube land. Huzaifa here, back again with more Khan Academy SAT problems. And what's up, Instagram people? Back again, broadcasting SAT Khan Academy problems live every morning, Monday through Friday. So let's continue where we left off. Last time we worked on isolating quantities. Today we are working on function notation problems. So without further ado, let's get into it. I'm going to jump right into the share screen right here. And let us begin. So again, if you guys are watching for the first time, I am seeing these problems for the first time, and I have not seen them before. That's part of the fun. If you're watching on Instagram and you want to actually see the problems being solved, go to my YouTube channel. And my YouTube channel, you can just go to YouTube, search for Scalar Learning, and you will find it there. Okay, this one is going to have to be pasted in two parts. It's one of these long ones. Let's see here. So it looks like what this question is asking is something along the lines of what, basically trying to, what is it? Let me see. Okay, it's kind of a transformation problem. So let me get the second part up on the whiteboard. The reason why I have to do these screenshots and move them over is because I realized early on that when I don't, it can be a little hard to read depending on what device you're watching these problems on. So when I do this, it makes it easier. You can definitely see everything better. It's a little brighter. It's a little clearer. Okay, we got everything over here. Let's begin. So the graph H is shown at the left. Which of the following represents the graph of F? Okay, so here's H, and it's kind of this semicircle like this. And what is F of X? F of X is literally H of X, but the X's are all made negative. Okay, so what's happening here? What happens when you apply a negative to the X of a function? And I'll tell you one thing, it's a reflection, but the tricky part is what type of a reflection is this? Is this a reflection around the y-axis, or is it a reflection around the x-axis? So here's how you can figure it out. Sometimes it's hard to remember this, right? Because you think, well, it's being applied to the x, maybe it's a reflection around the x-axis. It's actually a reflection around the y-axis. But let me explain why. Okay, so let's say it's like what's happening, you're flipping every x value. So every x value that was previously a positive one, right? Let's say it was previously a positive one. Now it's going to be a negative one because you're flipping it, okay? It was previously a positive. Oh wait, no, wait, hold on. Did I do this backwards? I may have done this incorrectly. Let me think about this for a second. If I plug it in, hold on. See, now I'm rethinking to myself, because when we do a negative on the outside, let me think about it for a second. If we make the entire function negative, then it's a flip. Yeah, that's a flip over the x-axis. Okay. So anyways, I believe that's right. So I believe we're flipping over the y-axis. And we can actually test it out too. See, sometimes I forget these rules too. I forget the exact nuances. If we look at y equals x squared, let's take that as an example. So y equals x squared just goes like this. And if it were y equals negative x squared like this actually wouldn't change anything, because it would still, every time you're squaring, it would still all be positive. But that's your proof right there that it flips over the y, because when you reflect across the y-axis, that's exactly what happens with this with y equals x squared. It flips on the y-axis. I'm pretty sure that's right. So we're going to have to go through and actually test it. So let's see. This one, it looks like A is where we're literally flipping it across the y-axis. I could do another example if I wanted to be absolutely certain. And let's see. One other example would be y equals x cubed, which is, like this. Again, I'm testing myself. Y equals x cubed. If we did y equals negative x cubed, where we plugged in a negative value every time, okay, when we had -1, okay, -1, let's say here, we get a +1, and it would flip it up. Yeah, see, it would flip it like this. So it would flip it around the y-axis. And if we okay, so I think that's right. So it's either going to be A or B if I'm remembering this correctly, and I'm pretty sure it's A. So let's just go ahead and double check. Oops. Here we go. Better be right. All right, it's right. So what does it say? It says, again, consider the transformation. Yeah, it is. It's a reflection of the y-axis. So anyways, in that example, even I had a little trouble remembering. I was pretty sure, but wasn't totally positive. You can start to play out some scenarios and test it out if you are in the same boat as I. Okay. Let's go to question number 2. This looks like a no calculator problem here. So let's go ahead and get this going. No calculator. The nice thing is on these no calculator questions, you usually don't need a calculator, so it's pretty good. Again, if you're joining on Instagram, jump onto my YouTube channel so you can actually see the problems being solved. Go to YouTube, search for Scalar Learning, and you will find the live stream there. Right, here's f of x equals x minus 1 over x, and then g of x, they give you 1 over x. Assume x does not equal 0. When they say this, sometimes people get hung up on these phrases. Don't worry about it. This is just to protect you from solutions or outcomes that are not real, and where you're basically dividing by 0. That's all it's doing. So you can more or less ignore it. Which of the following is equivalent to f of g of x? And they even did nice notation that's pretty clear. I sometimes call these nested functions. Okay, what's actually happening? You're basically plugging g of x in as your x for f of x. So how does this play out? Again, g of x is simply 1 over x. So I'm going to rewrite this as this, 1 over x. That's really what we're trying to do. And we're plugging in 1 over x for x minus 1 over x. Okay, so everywhere we have an x, we plug in this 1 over x. So what happens? Well, x is simply 1 over x minus, what happens here? 1 over, we're replacing that x with 1 over x. Okay, so what is 1 over 1 over x? Okay, a lot of times the way I like to do these problems, I make this into a fraction too, right? On top, fraction over fraction, 1 over 1 over 1 over x. This guy jumps up here, multiplies him. This guy jumps all the way to the top, multiplies him, or you just take the reciprocal of the bottom. But for some reason, that's how I like to visualize it. And we get 1 over x minus x. And let's see, can you simplify that? You could, but they give you the answer right here. They give you the answers, just how I wrote it, 1 over x minus x. All right, not too bad. Let's give it a shot. We've done it. It worked. All right, let's go to the next one. Let us see what this one gives us. Number 3, it says g of x equals that. Which of the following is equivalent to g of x? This is crazy because this is plugging itself into itself, and we are evaluating it. So again, I'm going to rewrite it like that because we're plugging into g of x. We're plugging in g of x, which is this, 8x minus 5 equals, okay, 8x minus 5, and this whole quantity is going to be replacing the x. That's what's happening. It's replacing that variable. So we have equals 8 times 8x minus 5 minus 5. This leapfrogs and distributes, right? We have 64x minus 40 minus 5. Combine these guys as like terms. 64x minus 45. Check that out. Boom. 64x minus 45 is B. That is our correct answer, unless I've made a mistake, which I haven't. Phenomenal. All right. We're already almost at 4. And we are on 4. That's pretty good. Let us clear the whiteboards. I'm planning to go in super early this morning because I'm doing some cool probability stuff in my class. I got to set that up. So this is going to work out perfectly. And guys, if you're watching on Instagram, make sure to jump on my YouTube channel on the live stream. Go to YouTube, search for Scalar Learning so you can actually see the problems that I'm solving. Going to be much better for you to actually see what's going on. Or if you enjoy listening, I know some people said they like to just listen and figure out what's happening. Up to you. All right, so now we got x values, f of x, g of x in this little table. Consider the table shown at the left. What is the value of g? Now we got the funky notation. All right. What is this notation? We got to remember this, that open circle. What is it? The open circle is literally what we've just been solving. It's just another notation. This is the same as these nested functions. Okay. I'm just going to straight up rewrite it. This is g of f. And then the last -1 means we're plugging in -1 for f. So first, we're going to evaluate this. First, start evaluate the most inside part. Okay. And so what do we have to do? We're trying to find f of -1. What is f of -1? We're basically saying, what is the value of f when your x value is -1? Well, so let's first find where x is -1. It's right up here. And I'm going to just kind of box this one off. What is f when x equals -1? It's right here. There's our f column, right? So this is 2. So now we've figured out that f of -1 is 2. Okay, we go inside out. Now we need to evaluate g of 2, because that's what f of -1 goes to. So now let's go to the 2 column. Where's x equal 2? Is right here. All right. Okay, x equals 2 right there. What is g of 2? This is the f column. Here's our g column. It's right here. G of 2 is 4. That's it. If you get the notation, these problems aren't hard. If you don't get the notation, they're very, very difficult. Well, essentially impossible if you don't understand the notation, but they are very doable, like I said, once you do. Okay. Question number 5. Here we go. Here we go with the finale of the whole ordeal. Let's check this out. Consider the graphs of the function f and function g shown below. What is the approximate value of g of f of 5? G of f of 5. So first of all, we're going to do this step by step. Let's figure out what is f of 5. We're basically plugging in whatever f of 5 is into g. And now we got a graph. So let's look at where's 5. Oh, here's 5. So right, f of 5, because we're plugging in this. We want to know this x value of 5 for f. Carry it all the way. Let's just go all the way up here. Here's f of 5. F of 5 looks to be 9. So now we know that f of 5 is 9. So really we're taking g of 9. Now I got to find 9 on the x-axis. This is just like the last one, right? It's just like the tables, except now this is on a function. I mean, on a graph. F of 9, where's my g? Oh, it's right here. And what is this value? 7. So g of 9 is 7. C. Let's go back here and try it out. Yeah. All right. Beautiful. That's it. We have solved our whole thing. All right, let's turn off the screen share. Oops. There we go. Boom. All right. So that's it for our rendition of Khan Academy SAT problems today. Again, check in every morning, Monday through Friday, and we've got Khan Academy explanations coming at you. These live streams are also saved on my channel, their own playlist, so you can peruse them at your convenience if you don't want to jump on live. And you can check it out that way. And best of luck with your SAT preparation. I wish you all the best. If you haven't done so yet, make sure to subscribe to my YouTube channel, and so you can be up to date on all the best test prep information, math, music videos, all that good stuff. And visit scalarlearning.com if you have any other questions, and always email me if you got specific questions, Huzaifa@scalarlearning.com. Like, comment below, and that's it, guys. Take it easy. Have a great day.